So I was saying this is called the gathered information. What is the answer? 4, positive. Now with that, you proceed and come up with what we call the decision rule. The decision rule. And this one is called two tails. Two tails. It's like this. When you're on this side, we have something like this. You are here, we will say you reject none. And this is 0.025. Maybe I need to show where that one is coming from. It is 0.05. You divide by 2. That is 0.025. 0.025. If you are here, this is called accept. Null hypothesis, which is 0.95. Here, we will say reject null, which is 0.025. This one is shaded like this. And now here, you have what we call minus Z critical. And this is positive Z critical. .95. 0.95. So this one, ile tulikuwa tunasoma kwa Z at 95%, and I hope you remember it was 1.96 and positive 1.96 here. Need to make a conclusion. Or before we make a conclusion, I need to remind you, note, when we say accept, we are saying it is insignificant. And when we say reject, we are saying it is significant. So then from there we make a conclusion. So as I had said earlier, if I were to come your way for a proposal, you go asking about me, you will be more interested in hearing my bad side. So, yes. Now, if the bad side you hear becomes significant, according to you, you will reject that proposal. But if the bad side you hear about me is insignificant, you will accept the proposal. So this tells you there is no single relationship that will be in that will not have problems. There will be problems, but if the problems are insignificant, you accept. And this is what I think I said the other day. Those of us who are married, we know that our spouses have issues which we are aware of. We are not happy about them. But we have accepted to live with them because they are insignificant, those problems. But if the problems become significant, chances are that relationship will be rejected. So in the language of the examiner, you'll be seeing more of these words, significant, insignificant. But in the language of the class, you'll be seeing more of this, reject, accept. So they are one and the same thing. So what now happens is ukishasikiza ile mambo umesikiza na wewe kwa kichwa yako una what you are expecting. Umesema anyone coming to me lazima akuwe ametimiza all these characters. So ukiangalia now what you have had, what you have, then you decide whether to accept or not to accept. Now for this question, these four unakuja kuitafuta. Hapa ni minus 1.96, hapa ni 1.96 positive. So if you are told to look for 4, where is it? It's on the upper side, where we are told to reject. So you say reject. Reject none. Now, in good manners of communication, when someone asks you something, it is required you state your position. You either say yes or no. But it's also required you do two other things. One, you say, why have you said yes or no? And number two, you say the meaning. Otherwise, if you, even in an interview, if you go and you are asked something and you are just saying yes, no, it shows an element of arrogance or an element of rudeness. You should say yes because of this and this, no because of this and this. Not unless whoever is asking you the questions had come out in a very clear way that I only require a yes or no. Yeah. Otherwise, when you just say yes or no, it could also even manifest malice because you're not able to justify. So you must tell us, we are going to reject. Why? Since Z calculated is greater than Z critical. That is 4 is greater than 1.96. So that is the reason. Then, and you know this, there are some people you tell something, and more so if it was opposite of what they were expecting you to say, they don't seem to understand. So anakuuliza unamaanisha meaning. So the meaning of that. Now this is where you explain in very clear, very simple language. Na sasa atupoelewa from that point sasa unaachana nayo kusoma. So meaning, this meaning is expressed in the words of the examiner. The words of the examiner are gotten from what you had been told to check. So we had been told to check whether what? Whether? Yes, whether the machine has drifted from its correct setting. And now that we have rejected null, ndio hii, ilikuwa inasema they are equal. So if they are equal, we kumaanisha they had not drifted. But now that we reject this, then we must accept this. And this is the one that is saying they are not equal. And the meaning of that is that the machine has drifted. The machine has drifted from its correct setting. The machine has drifted from its correct setting. The machine has drifted from its correct setting. Okay. Read for us the second question.
A punch machine makes holes in metal washers. The machine is intended to operate so that the hole is on average 4.00 millimeters with a standard deviation of 0.20 millimeters. A sample of 25 washers is selected at random, and the mean diameter is found to be 3.88 millimeters. Is there any evidence at 95% coincidence level to suggest that the machine has drifted from the correct setting?
Thank you. So the first thing is the population known. Huh? Yes, good. And it's a case of a single sample and a single mean. Okay. So these hypotheses, they are just stated, as I said earlier. The sample mean was found to be what? 3.88. Now 3.88 should be equal to the population mean is 4. Population mean is 4. Now this one, you can do like what I said earlier. They are not equal to. Now this one is which one? So now we can see X bar is less than B. That is 3.88 is less than 4. 3.88 is less than 4. Significance level that remains. The formula remains. So this will be 3.88 minus 4.00. We divide by standard deviation is what? 0.2. And the sample size is 25. -3. So let's do now our decision rule. And our decision rule will be 1 tail. So this is 0.05 divided by 1. That will give us 0.05. So in that case, we have something like this. So because it is less than, we want the lower side. This one is what we want, so that this one and this one, this is going to accept the null, which is 0.95. And when you are here, you will reject, which is 0.05. And then here is minus Z critical. And as you can remember from our confidence intervals, this one will be 1.65. It's minus 1.65. So sasa we are going to say what? In our conclusion. When you look at this -3, you can see it's on the lower side. So we will say reject because Z calculated is less than Z critical. That is -3 is less than -1.65. Is less than -1.65. It's less than -1.65. Meaning, tulikuwa tumeulizwa whether the machine has what? Has drifted. So the meaning is that the machine has drifted. The meaning of that is that the machine has drifted. Okay, Sarah read for us the part.
The heights to which average plant growth in the nursery months plantation is approximately normally distributed in a mean of 23 centimeters and a mean of 20 centimeters. Last year, a box of 15 of the plants received by mistake double the usual maximum. The mean height of the plant in this box was 55 centimeters. Is there any evidence of at 95% confidence level to suggest that the extra fertilizer has a beneficial effect?
Thank you, that's good. So is the population known? Good. Are we dealing with one sample? Are you dealing with one sample? Yes. And we are comparing the mean. So it's a case of known population, single sample, single mean. Then we now look at the sample mean. Uto to seedlings tupatikana na mean height ya 50. Is it 53? 55. And the normal is what? 53. That's the population one. So in stating the alternative hypothesis, you can see the X bar is greater. So we will say 55 is greater than 53. 55 is greater than. So if it's greater than, the significance level is 0.05. And then the test statistic remains. The test statistic remains. So to substitute, this will be 55 minus 53. You are told they had a variance of what? 12. So that means you get the square root of 12 so that it becomes a standard deviation. You divide by the square root of the sample size. The sample size, how many seedlings were considered? 15. So the seedlings that were considered, there were 15. What do you have? 2 2.24. So the decision rule is still one tail. And it then looks like this. Because we are saying it's greater, you shade the upper side. You shade the upper side this way. This now becomes reject. Reject null hypothesis. This is 0.05. And if it is anywhere here, you will advise that we accept the null hypothesis. And this is positive, say critical, which we know is 1.65. Now, when you compare, you can see this one is on the higher side. And therefore, we come here and say we will reject. And it's only a coincidence that those three have suggested we reject. So don't grab that every time it's time to reject. It's only a coincidence. It will be tied to accept. 2.24 is greater than 1.65. It's greater than. Just to summarize the next.
PLC produces light bulbs. For one particular type of bulb, it has always been claimed that the expected lifetime is 1,500 hours. In order to test a new batch, a sample of 10 was taken. The midlife of the sample was 1,410 hours, with a standard deviation of 90 hours. Does the evidence at 95% confidence levels suggest that the expected lifetime has changed from 1,500 hours?
Thank you. Good. So is the population known or unknown? It is unknown. Good. So here we will say unknown population. Unknown. The population is unknown. It is a case of single sample and single mean. So what we need now is to do the hypothesis. So the hypothesis, you tell me, they have said the mean of the sample was found to be what? 1410. And the expected one is supposed to be 1,500, eh? The population. So that is X bar is less than mu. That is 1410 is less than 1,500. 1410 is less than. Now the significance level remains, but the t-test now changes. The t-test changes. So the test statistic becomes t, which is given as x bar minus mu. You divide by s, which is divided by the root of n minus 1. N minus 1. So sasa our T calculated will be 50, not 55, will be 1410 minus 1500. Divide this by, what is the variance that we are given there? Or the standard deviation? The standard deviation is what? 90. And the sample size was 10, so 10 minus 1. What is the answer? It's taking you too long. So the decision rule is also 1 till, and here we have degrees of freedom. Degrees of freedom will be 10 minus 1, which is 9. That's how we get the degrees of freedom. 10 minus 1. And then this 0.05 is divided by 1, and we have 0.05. That is at 95%. So with that, we design our nice diagram. And that diagram, because we are saying less than, we are on this side and this side. This one is you reject null 0.05. And then this one you accept null, and here you get minus T critical. So go to your T tables. You go to where is written 1 till confidence. 1 till confidence. And then you move to the left to where there is 95%. And then we remove it where we have 9 degrees. Tell me what is there. 1.8331. So it's negative. So we will then advise. That we reject null since T calculated is less than T critical. that is minus 3 is less than minus 1.8331. That's what we shall advise. So what does that mean? It means that the bulbs have shifted from the normal 1500. The expected lifetime has shifted. Expected lifetime has shifted from the normal 1500. Okay. Yes. Next.
A supply of electronics components take a product which sometimes fail immediately. It is used. The supplier tries to control his manufacturing process so that the proportion of faulty products is less than 4%. A batch of 500 components is supplied entity proved to be faulty. Is there any evidence that the manufacturing process has gone out of control and too many faulty products have been produced?
Thank you. Thank you. That's good. So the population is unknown, and it's also a single sample. But this is not now mean, but is what? I told you when they are comparing one or two, two items, that is called single proportion. So it's a case of single proportion. And if it is a proportion in the hypothesis, we normally say that the sample proportion is equal to the population proportion. That is, the sample was found to have a proportion of what? They found how many out of how many? 28 out. So divide 28. 28 out of 500 is 0. What?
0.56.
Yes. Now this one is the sample proportion, and the population proportion was 4%. Is that? So 0.04. Sasa, this one is a case of sample proportion being greater than population proportion. That is 0.056 is greater than 0.04. It's greater than 0.04. Alpha, that remains. Then we have Z here, which is sample proportion minus population proportion. Now this is divided by the square root of sample proportion, 1 minus sample proportion. Divide this by sample size. You divide by sample size, and this is square root. So our Z calculated will then be 0.056 minus 0.04. You divide this by 0.056. 1 minus 0.056. You divide by n, which is 500. Which is 500. One point. 1.54. So let's get the decision rule. Decision rule. This once again is one tail. Is one tail. And it's a case of 0.05 divided by 1, which is 0.05. Because you're saying it's greater than, then it is this side, this way. So this one we accept null at 0.95. This one we reject null at 0.05. And this is Z critical positive. And this one we know is 1.65. 1.65. Then you will make the conclusion. What have you said about the conclusion? You reject the null. You accept. You accept null since Z calculated is less than Z critical. That is 1.54 is less than 1.65. Meaning the process has not gone out of control. As a meaning, the process has not gone out of control. Salary into the next.
The sweet sugar company has the production lines for the trading of 150 sugar. In the data collected over a long period of time, the production manager estimates that the population standard deviation of the weight delivered for line 1 is 0.02 kg, and for line 2 is 0.04 kg. A random sample of 10 bags is taken from line 1, and the mean weight in the bag is found to be 1.018 kg. A similar random sample of 12 bags is taken from line 2, and the mean fill is 0.982. Is there any evidence to suggest that the two production lines are dispensing mean amounts of sugar?
Thank you. So is the population known?
Yes.
So it's a case of known population. It's a case of known population. We have 1 or 2 samples. 2 samples. And we are comparing what? Means. So when you have 2 samples, we normally say it is means difference. Means difference. It's the means difference. So in the hypothesis, we normally say that X bar 1 is equal to X bar 2. X bar 1 is equal to X bar 2. The first sample had a mean of what? 0.018. And the other one had a mean of 989. So there's a case of X bar 1 is greater than X bar 2. That is 1.018 is greater than 0.989. It's greater. Some people will say X bar minus X bar 2, right? Instead of saying equal, so that you tell us equals to 0. But we prefer to do it that way. Then the significance level that remains, and we are still using Z. We're still using Z, and Z is equal to X bar 1 minus X bar 2. The standard deviation 1, standard deviation 2, you divide by the root of sample size 2, and here you divide by the root of sample size 1. That way. So our Z calculated will be 1.018 minus 0.989. You divide the first sample ilipatikana na standard deviation ya 0.02 na ilikuwa na sample size ya 10. Huyo mwingine alikuwa na standard deviation ya 0.04 and the sample size was 12. You solve that. Uh-huh. 1.62. So decision rule remains kama hiyo exactly, and even the conclusion will be copy quickly at that point. What does that mean? Tulikuwa tumeulizwa we test whether they are dispensing mean amounts. Mean is the other word for equal. So that means they are dispensing equal amounts. Meaning they are dispensing equal amounts. So you shall do question that is question 7. Question 7 is on the same theme. So the example like we have answered this one. So now we go to patience to submit question 8.
A certain type of polymer is made by a batch production. 10 samples N1 and N2 being taken from each of 2 consecutive batches, and the percent of 24x in each sample mixtures. For batch 1, the mean percentage per sample was 8.2% X1 with a standard deviation of 0.70% X1. For batch 2, the mean content of chemical X of 67.0x2 with a standard deviation of 0.74% X2. Is there any evidence at the 5% confidence level to suggest that the 2 batches contain different percentage of chemical X?
Thank you, that's good. So this is a case of unknown population. It's a case of unknown population. It's a case of unknown population. And if it is a known population, we have 2 samples and we are comparing means difference. Sasa, the first sample ilikuwa na percent ya 60 watts. 68.2. Huyu mwingine ndio kuna 67, 67. So it's a case of x bar 1 is greater than x bar 2. So 68.2 is greater than 67. It's greater than 67. So alpha is, as you can see, the test statistic T is x bar 1 minus x bar 2. Now this one is divided by the square root of n1 minus 1 s1 square plus n2 minus 1 s2 square. Now this one is divided by n1 plus n2 minus 2 times 1 out of n1 plus 1 out of n2. Now you get the square root. So T calculated will be 68.2 minus 67. You divide by the first has a size of what? The samples, are they 10? So the sample sizes 1, 10. No, kuna mahali nasoma kama week. There are 10 each. So it is 10. 10 minus 1. Na standard deviation ya kwanza ni 0.7. That's the first one. So you square that. plus 10 minus 1. Hiyo ingine ndio iko na 0.74. 74. You square that. You divide by 10 plus 10 minus 2. Then you see times 1 out of 10 plus 1 out of 10. So you give me the answer there. And then this one will remain, but the degrees of freedom now will be 10 plus 10 minus 2. That will be 18. The degrees of freedom. So this will be positive T critical. So compute that and then you draw that so that we make the conclusion. Very fast. What is the answer here? 3.73. 3.73. So draw this, alafu utasoma tu venye tunasoma ni wanted kwa sasa utateremka kwa degrees za 18 degrees. So what have you said? We accept or we reject? We reject. Null hypothesis since T calculated is greater than T critical. That is 3.73 is greater than. Umepata nini hapa? 1.341. 7341. So the meaning of that is that the batches contain different. Walikuwa wanauliza whether they contain the same ama different percentages. Yeah, so they contain different percentages. Contain different percentages. So from there, we have what? We have those two others that follow. You shall do them. They are the same concept. The next one is what? So you shall do question 9 and 10. So this is to submit 11.
The internal auditors in a large company are interested in the system by which incoming invoices are processed. They take a random sample of 50 completed invoices and check them with details for correctness of procedure. 4 are about to be defective in some way. The auditors then suggest some modification of the procedure, and these are implemented, allowing take for the clerks to adjust the new procedure. The auditors then take a random sample of 60 completed invoices. These times define 3 incorrect ones. Is there any evidence that the new procedure has improved the error?
Thank you. Okay, that's good. So now, the case is unknown population, 2 samples, but it is a case of proportions. It's a case of proportions. So it is proportions difference. It's a case of proportions difference. Proportions difference. It's a case of proportions difference. So with proportions, we are going to have the null hypothesis being first sample proportion is equal to the second sample proportion. That is, in the first case, they found how many out of how many? 4 out of 50, that's the first one. Should be equal to, they found how many? 3 out of 60. That is where I noticed so that we are able to connect how they arrived, they came about. So 4 out of 50 is 0. What? 0.002 is the same as, na huyo mwingine, it is 0.0.
No, the first one.
The first one is 0.08. Aha, na huyo mwingine 0.05. 0.05. So in the alternative, the first sample proportion is greater than the second sample proportion. That is 0.08 is greater than 0.05. It's greater. The next is significance level, that remains. And then the test statistic is given like this. Z is equal to sample proportion 1 minus sample proportion 2. You divide this by the square root of sample proportion 1 minus sample proportion 1. You divide this by sample size 1 plus sample proportion 2, 1 minus sample proportion 2. You divide by sample size 2. And all this is at the square root. So that your Z calculated will be 0.08 minus 0.05. So this is 0.08. 1 minus 0.08. You divide by, the first one was 50, plus 0.05. 1 minus 0.05. You divide this by 60. Then you will tell me what is the value. And because it is a case of greater than, this one is Z critical, so hii haina mambo na degrees. Degrees of freedom are not there. It's a case of Z critical, which we know is 1.65. What is the answer? Hapa
625.
so what do we say? We accept, Even 1.65. Have you finished that one? Okay, so in the conclusion, you say accept. Null hypothesis since accept null hypothesis since Z calculated is less than Z critical. Is less than Z critical. That is 0.625 less than 1.65. And the meaning of that, we've got to meulizwa whether it has improved the error rate. So now that we have accepted, the meaning is that it has not improved, or the error rate has not improved. Okay. The error rate has not improved. The error rate has not improved. Good. The next question is number 12. Now that one we can't do now because time in Kuisha, we have just 5 minutes. It's called chi-square. So we'll stop at that point here to the next lesson. Okay, we were to talk about the makeup class. Sunday, ni Sarah huko napatikana. Ama things have changed. Oh, okay. So kama tunaweza, I then propose we still meet this Sunday from 6:30 to 10:30. To skume. Yeah. The next topic now is linear programming. Those who are online, I'll send you the copy. Those who are physical, you get the copy before you go. Yeah. Thank you. So we meet on Sunday.